Hey everybody, it's Dr. J, and today we are talking about a relationship that occurs between our Ka and our Kb. Let's talk chemistry. All right, so let's consider this base reaction right here. We got NH3 plus H2O, give me NH4 plus and OH, right? We understand this is going to be my conjugate acid. And when we go to do our equilibrium expression for our Kb, in this case, because it's a base, right, it's going to be NH4OH over NH3. So we're not including water here because it's a pure liquid. So when we have our Kb value, a couple different things we're going to realize, right? Because we're talking about the relationship between Ka and Kb, right? So OH, should we go back and realize OH is equal to Kw over H plus concentration. So because that is the case, if we substitute this value for our OH concentration, it's going to look like this, right? NH4 plus times Kw over H plus times NH3. So when we go to look at that equation, what's that look like, right? This is now going to tell me that the following equilibrium, when it's multiplied, in this case by Kw, it's going to look like this, right? NH3 and H plus gives me NH4. So if I have that equation and if I reverse that reaction, right, that's just going to be our acid equilibrium, right? So if we reverse it, now I got my NH4 plus giving me my NH4 3 and H plus concentration. If we go to write the value for my Ka, now that's going to look products of reactants, right? NH3, H plus gives me NH4. Okay. So now we have an entirely, right, new equilibrium expression for my Ka. Okay. So basically we can note, right, that this expression here, right, is basically our relationship. That Ka is NH3, H plus over NH4. And then if we flip it, right, the flip side of that, or the reverse, is our Kb. NH4 plus over NH3, H plus. Okay. So this is our relationship between our Ka and our Kb, right? And they're related all because of Kw. That's how they're related, everybody. Because of the Kw, this is how our Ka and Kb are related. So this relationship, right, goes back to this. In this case, Kb equals Kw over Ka, or Ka can equal Kw over Kb. And if you multiply your Ka and Kb, you get your Kw, all right? And this is just our, in this case, our K values, right? And then if we look at our pK values, pKw equals pKa plus pKb, right? And then pKb will equal 14 minus pKa, and pKa equals 14 minus pKb. So if you know this math relationship, right, this can help you, right, going forward. If you are missing a couple different things, if they're asking you some questions, it's like, okay, I don't know this value, but I know how I can get to that value by using this relationship here, right? So once again, if you don't have enough information, you might have enough information. You just might have to convert a couple of different things. So for example, right, when a Ka value is given for a base, it is really the value for the conjugate acid of that base. So for instance, like we got a base here, NH3, and give me Kb, it's 1.8 times 10 to the negative 5. The conjugate acid of this base is NH4 plus. So we can know the Ka value for this conjugate acid, in this case, 5.6 times 10 to the negative 10. So if we multiply our Kb and Ka, right, together, we can actually find our Kw. 1 times 10 to the negative 14. So we know that's not going to change. So this is just an example, right, of if you are given one piece of information, you can use that piece to convert it to something else, right? Because of this relationship, all thanks to Kw. KW is key here, y'all. It's key.